Hi, this is Agnito Sinha, and this is part of my homework submission for assignment 3 of CS 441 at UIC. This is the ongoing part of the LLM project that we are doing, and this is the final part of it. In this project, we are building LLM microservice, basically a client server architecture using AWS and Docker. So let me give you a brief introduction of what it is. So yeah, as I've said, in this project, I have built a client-server architecture for creating an essentially an automated conversational agent. Basically, an LLM will talk to an LLM and they will produce a conversation. And my job is to facilitate the conversation and also show you what the conversation was, basically. So I have used Akka HTTP for creating the RESTful API. It's the server part of it. And this takes in a prompt from client or user and gives a response back, essentially. The client um, structure is basically is that it calls the server with with the initial prompt. It gets a response back from the client, and it then passes the response to Ollama, which is hosted in my local machine. And Ollama is used to basically create the next prompt that we will give to the server. The server is running in this project. I have used a Titan, Amazon Titan system, which is hosted in Bedrock in AWS. And yeah, the client basically facilitates this conversation and keeps a record of the conversation, and in the end, it shows us. Now, I'll be moving on to the server flow, the server overview. And if you can see here that the client is sending the server code, which is hosted on EC2, first of all. It is sending the prompt to the server via API. This API has been created with Akka. The server then takes this prompt and gives it to Lambda, AWS Lambda via gRPC. And Lambda then takes the prompt and passes it to AWS Bedrock via the SDK. Because Lambda and Bedrock are running on the same platform, they don't need any special access. I mean, like access keys or secret access keys or anything like that. Now, Bedrock, of course, takes the prompt and gives a response back to Lambda. Lambda then gives it back to server, and server gives it back to client. This is the basic the server architecture. Now I'll be moving on to the client architecture. If you can see here, uh, this is the client standalone code. This is my code. So what is happening it is the first prompt we are giving it to the client, the first one. The first prompt is sent to the server, and client gets a response back from the server, like the previous slide that I showed you. Here it from server Lambda Bedrock, and it goes back to client. Though, so then client then sends it to Ollama, the response, and Ollama generates a next prompt to be sent to server. And this happens till a condition is met, an explicit hard-coded condition, that is I less than max terms. Of course, we can configure max terms. It's in the application config file. And if I is less than max terms, then this conversation keeps on happening. If the termination condition is met, then it exits. Now I'll give a brief overview of the various AWS services used. And of course, EC2 is for hosting the server. Lambda is for like it is for like the server calls the Lambda via gRPC and Lambda calls Bedrock. Bedrock is, of course, for the main LLM model that is hosted on Amazon servers, basically. ECR is for hosting the Docker file of server. I'm running the server via Docker container. ECR is the place where I'm uploading the Docker file and running it on EC2. IAM is for identity access management. That's for configuring roles, and the IAM part was like it was initially needed for you can't configure Bedrock without IAM. That's a prerequisite of Bedrock. And also for initial testing when I wasn't using Lambda or the API gateways. So I had to call Bedrock directly via the with using the secret keys and the secret access keys. S3 is for storing the jar for AWS Lambda. Lambda takes the code from S3. And API gateway is for basically triggering the Lambda, AWS Lambda from the server. Okay. So that's the end of the presentation. Now I'll move on to the code to give you a brief overview of it. First, I'll go to the server code. The server code is kind of the main part of this project, and so what is happening in the server? So this is the Scala. Yeah, this is the main function. Basically, what it is doing is in the service, I've created a REST server. Basically, this is for handling the Akka REST um, the REST API. It exposes the API endpoint. So there are two API endpoints. One is path single slash, which is like kind of for testing if the API is running. And the main one is the path generate. It basically a post request to slash generate. And this is the main part. And we have to give a body with the query. So this is and it calls the LLM service here. Basically, I'll just saying it briefly. LLM service hits the AWS Lambda model via gRPC. I've used the protobuf files for this. This is my LLM.proto. And um, yeah, these are my LLM.proto, and this server hits Lambda, uh, the Lambda code via the gRPCs. So, and gRPC gives, of course, there is a, I have, if you can see, there is a Bedrock client implementation on here, but it's technically not being used. This is kept as a fallback plan. And initially, in the initial days when I was testing it without Lambda, I was calling Bedrock from the client directly, but I'm not doing that anymore. I'm calling Lambda. So this file is still there. This is in the later days, it is more of a fallback plan. Although that's not needed. Of course, AWS credentials are here for invoking the Bedrock, which we are not doing. I'm not opening the credentials file. And yeah, that's main gist of the client architecture. Now I'll move on, sorry, the server architecture. Now I'm going to show you the client architecture. The client architecture is pretty simple. It's this conversational agent. If you can see, just these four lines of code basically summarize it. Basically, it gets the response from the EC2 service. It generates the next prompt via Ollama service. These services are defined quite explicitly in these two files. And this conversation continues until until the terminating condition, the turns remaining minus the terminating condition is met. The terminating condition is being defined here. Max runs equal to 5. So it's like a 5 messages back and forth in this code is what is actually happening. Okay. That is more or less for the client architecture. It's pretty simple. One thing to know is that the client code isn't a server initially. It's a standalone code. It starts, it executes what it requires, and it shuts down. And we can pass the initial prompt via the terminal or via the Docker Compose. Now, uh, the Lambda code. The Lambda code is also pretty simple. It's just one file. If you can see the project hierarchy here, the project structure, the directory structure. It's just one line of code, and yeah, pretty simple. It just takes the request from server and executes, and again sends it to Bedrock. In this case, we are using the Bedrock. Yeah, the Bedrock client from the SDK. We are not using any API or anything. And of course, because they are running on the same platform, so they don't need access keys. And for the final thing, I have arranged my project in such a way. Of course, there are three different projects, as you can see here, but I have only uploaded one file, one repo to GitHub. And this is how I've arranged my project. The client code is here, the server code is here, and the Lambda code is here. The conversations folders stores the conversation in both text file and JSON file, and the logs are for the latest logs that run. Of course, there are Docker Compose, two Docker Compose. I'll explain shortly in a while why. Let me open this directory. This is the root directory. I've named it root, so it's easier for me to understand. This is the Docker main Docker Compose. It runs the LLM server and the LLM client both together. Of course, I'm not running the LLM client on AWS. I'm just running the server on AWS, and I'm running the client locally because Ollama requires a lot of memory. So yeah, this is for both the LLM server and the LLM client, and Docker Compose.ec2 is just for LLM client, and instead it will hit this EC2 URL. Here in the Docker main Docker Compose, it is not hitting the EC2 instance. It's hitting the LLM server. This one, the LLM server that has been created here. If you want to test it locally, just run Docker Compose. If you want to test the client and hit it to EC2, run the Docker Compose.ec2. Pretty simple. Okay. Now I'll just move on to the AWS consoles, and I'll show you what I've used in AWS, the configurations I've done. Okay, so for EC2, there are two instances because one is without Docker and one is with Docker. This is the Docker one. Both are running the same code. Both are running the server codes. So yeah, I'll SSH into this just a short while after. This is the ECR for hosting the server Docker container, and this is the LLM service as you can see. There's a Lambda file. Lambda, yeah. If you can see, the trigger is API gateway. And the code, yeah, it's running Java 11. Of course, I've written the Lambda code in Scala. And even the handler. And yeah, that's pretty much it. And the API gateways for hitting the server. If you can see, there is a post. This is for the Lambda. This is for the trigger of Lambda. S3 is basically for uploading the Java file. Here is the jar file that has been kept for uploading it to Lambda. IAM I have used for configuring the access keys and roles and whatnot. There's only one user. I'm using it for everything, and I've named it after myself. And yeah, for Bedrock, I have, let's go to model access. I have access to three models basically, and I'm using the Titan, the G1, the one by Amazon. That's my overview of AWS. Everything is running. Now I'll just SSH into the Docker and start this Docker. I've SSHed into it. You can see there are no Docker files currently running, but an image has been pulled from ECR. This is the one. If you can see, if you let me just show you the ECR one. Service, yeah. Um, yeah, if you can see, it is this one. It starts with 390 and it ends with LLM service 1.0. It's the same one, 390 and ends with LLM service. So I'll run this one now. Yeah, if you can see, it is saying that the server has started on port 8000 and it has mapped the localhost 8000 with the Docker 8000 port. Now I'll run this Docker Compose, this one, the EC2 one. Let me make sure everything is down. Yeah, it's down. Let me clear the screen once. Compose, chef, Docker Compose, start EC2, and up. Yeah. You can see that the logs are being displayed. It's hitting this HTTP, this one. Sometimes it takes a bit of time because Bedrock, for the initial prompt, it can be a bit slow. Yeah, it's running. Oh, and for another thing, I've used Llama 3.2 for Ollama. It's the latest version of Llama and it works fairly good, I guess. It has exited. Now we can find the logs and the conversations here. It's currently 1852. So these are the latest ones. I'll open the text file. Yeah, the initial prompt was tell me about artificial intelligence. It was written in the Docker Compose. We can change it, or we can just give it just run this Docker from the terminal and give it there. Give the prompt there. No issues. So it will tell me about the human part is basically the first one is we are providing the prompt. Assistant is basically Bedrock. The next human onwards, it's Ollama. Ollama is saying the conversation, and you can see here it's given turn one, turn two because max turns was five. There is only till turn five. After turn five, it gets terminated. So this is the conversation. A final thing that I would like to show, you can see the EC2 is running, the Docker is also running. The final thing I'd like to show is how you can test it on your own PC. It's nothing, just do Docker Compose up. So it will run the default Docker Compose, not the EC2 one. See, the LLM conversation agent has started along with the LLM microservice. and LLM microservices generating prompts. Both are running locally. The server and client are running locally. However, Lambda is still running. If you are not running Lambda, if you're not uploading the code to Lambda, tough luck. Conversations, yeah, it's 1854. These are the latest conversations. All the conversations are it's mapped. The Docker Compose maps with the volume of Docker. So this folder is mapped to it. So yeah, these are the latest conversations. Yep, that's pretty much it. Oh, another thing I forgot to show. Yeah, this the logs have been generated. For brevity's sake, let me just so you can make sure that it is running on AWS. AWS. Yep, I'm running the Docker once again. I wanted to hit it from Postman once to show you that it works. This is the slash. If you can say it's just a single slash. If I send it, it gives servers running post to generate. If I this is the post, this is a what is a cat, and if I hit the post prompt, sorry, a prompt is displayed here. What is the cat? The domestic cat is a small carnivorous mammal. And for the logs, yep, what is a cat? You can see it. Let me retry this. What is yeah? We got a response, and in Docker, yep, it's working fine. So that's all. That's for my video. That's for part of my video submission, and I'll be uploading this folder to GitHub if you want to access it. And yeah, that's all from my side. Thank you.